Hello, 6th graders. We are now going back into the 7th grade book, which is the red book, and we're going to start talking about expressions and equations. That's what this entire chapter is over. So before we go any further, I want to give you a problem, and I want you to do it yourself to see what you know, because this is something that you should already know what to do and how to simplify it. So I'm going to have a problem. I want you to pause the video and do the problem yourself. Here's the example that you should know from previous grades. So evaluate when x is -2 and y is 4. Here's your expression. I want you to evaluate when x is -2 and y is 4. Pause the video and simplify it yourself. Now what you should have done is plugged in -2 for x and 4 for y. So that will give us 6, and then make sure we start using parentheses. Remember parentheses. I've told you that I want you to start using parentheses. So we plug in -2 for x and we plug in 4 for y. Notice I didn't put parentheses around the 4 because I'm not multiplying anything or taking anything to the second power here. So now we simplify. We have to follow order of operations. -2 to the second power is 4. 4 plus 2 is 6. I now would multiply, so that would give me 24 minus 18 plus 8. I go left to right. 24 minus 18 plus 8 will give me 14. So the correct answer you should have gotten was 14. So we're starting with section 3.1, which covers algebraic expressions. This section covers one of the most important topics that you're going to learn and use throughout your mathematical career, and that covers expressions. So this right here is so important. Make sure you write this in your notes, put a star around it, highlight it, whatever you need to. Parts of an algebraic expression are called terms. Like terms are terms that have, this is it, the same variables raised to the same exponents. A lot of students think that like terms have the same variable. They do, but they also have the same exponent. So please make sure you understand that like terms have the same variables raised to the same exponents. Let's write down an expression. Now this is an expression, 9x minus 2 plus 7 minus x. This has 4 terms. Now I want you to understand that in this expression we have 4 terms. The terms are 9x, -2. Now you're like, well, that's a minus 2. But remember, I'm going to write this off to the side here. It's the same as 9x plus a -2. So -2 and -2 mean the same thing. Our next term is 7, and our next term is -x, or -1x. Make sure you understand that like terms are not all of these things. We have to identify the like terms within all 4 of these terms. So the like terms are terms that have the same variable raised to the same power. So like terms would be 9x and -x, because notice that they both have the variable of x raised to a power of 1. So they have the same variable at the same power. The other like terms we have are -2 and 7. These have no variable. These are what we call constants. So make sure you understand that all of these are called terms. Like terms are terms that are either constants, which are just numbers, or terms that have the same variable raised to the same exponents. So for example number 1, we're going to identify the terms and the like terms in each expression. So in this expression, let's write down, let's make it a fun one. Let's do z squared. Notice I always put this here just so it doesn't look like a 2. Z squared plus 5z minus 3z squared plus z minus 7. So let's first write all the terms. So the terms, we have to identify all of the terms. Well, we have 5 of them. We have a z squared. We have a 5z, we have a -3z squared, we have a z, and we have a negative 7. Those are our terms. Well, the like terms are terms with the same variable with the same power. So if we look, same exponent, same variable, we have a z squared. Do we have any other terms with a z squared? We do. So z squared and negative 3z squared are like terms. We also have a 5z and plus 1z. So we have a 5z and a z, which are also like terms. And then the negative 7 is just kind of by itself. There are no like terms that go with negative 7. So we've identified our terms and our like terms within this expression. All right, now this is another important concept here. So please make sure we definitely make note of this. And I have a star next to it because it's important. And I like stars. So let's use a star. An algebraic expression is in simplest form, ding, 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 make sure you know that, when it has no like terms and no parentheses. When you combine like terms, or to combine like terms, you're going to add or subtract the coefficients. Now remember a coefficient. If you don't know what it is, I would suggest you write down the definition. A coefficient is the number that precedes the variable, the number that's in front of the variable. So, let's do a problem. If I give you something that looks like this, 3/4 y plus 12 minus 1/2 y minus 6. We have to simplify this. In order to simplify, you are going to combine like terms. So I'm going to color code this. I see that I have a y term right there. I see I have another y term right here. So I have 3/4 y minus 1/2 y. I also have constants, which would be 12 and minus 6. So we're going to combine like terms by adding or subtracting the coefficients. The coefficient of this y term is 3/4. The coefficient of this y term is negative 1/2 or minus 1/2. So we're going to take 3/4 y minus 1/2 y. 3/4 y plus a negative 1/2 y, or 3/4 minus a half, would give us 1/4 y. The 12 minus 6, positive 12 and a negative 6. That's going to give me 12 minus 6, which is plus 6. So my simplest form of this expression is 1/4 y plus 6. I cannot add 1/4 plus 6 together. These are not like terms. Why? Because this has a y, this does not. Therefore, they do not have the same variable with the same power. They are not like terms. And we're just going to jump to a fun one. Example 2, simplify each expression. So we want to simplify this. So if I want to simplify this expression, now I look at it, and you're going to go through and just start finding things that have the same variable with the same power, the same exponent. So here I see an x squared. I see another x squared. Those are my like terms. So let's add them together. 5x squared minus 2x squared gives me 3x squared. And if you want to cross them off as you go, you can do that. Next, I have a y term. So I have negative 3y, and plus 5y. So negative 3y plus 5y would give me plus 2y. So those are gone. Then I see a positive 9x. Here's a minus x. Now remember what I told you. What number is right here? It's a 1, so that's minus 1x. So 9x minus 1x gives me 8x. And lastly, I have 7 plus 1. And 7 plus 1 gives me 8, so I have plus 8. So my answer is 3x squared plus 2y plus 8x plus 8. Now, if you actually have that in different orders, for example, let's say you had this, 3x squared plus 8x plus 2y plus 8. If you have that, it's the same answer. This right here is the same answer as this. It does not matter the order right now. Why don't you try B yourself? 7 plus 4p minus 5 plus p plus 2q. Pause the video and try that yourself. If you did it correctly, you would have added the 4p and the 1p together, so that would have given you 5p. The 7 minus 5. So then we do 7 minus 5, and 7 minus 5 gives us positive 2, so we put plus 2. The next thing we look at is the plus 2q. The plus 2q just comes down, which gives us plus 2q. Now, one thing I want to make note of is that you can actually put this in different orders. If you took 7 minus 5 first and just wrote down 2, that's also correct. And then plus 5p, plus 2q, these can be in different orders, and it still means the same thing. So either one of these answers would actually give us the same thing. When simplifying like terms, you're going to have to use the distributive property to simplify expressions in which you have to multiply to a group of things. Now, let's review distributive property. If you have 2 times, let's say, 5x, you know that the parentheses means to multiply. So this expression would be 2 times 5x, which will give us an answer of 10x. Now, the distributive property is used when you are multiplying more than one term inside parentheses. So for example, if I gave you 5 times 2x plus 3, what this means is you have to take the 5 and you're going to multiply it to every term inside the parentheses. So this is going to be 5 times 2, and specifically be 5 times 2x. And then you take 5 times 3. And this will give you 10x plus 15. Now, remember, you cannot combine 10x plus 15. And why is that? Because 10x and 15 do not have the same variable and exponent. Therefore, they are not like terms. So your answer would actually be 10x plus 15. So let me give you an example that would use the distributive property. If I gave you, for example, 3 times q plus 1 minus 4, you first have to get rid of the parentheses. You cannot add q plus 1 because they are not like terms. So we're going to take 3 times q, which gives us 3 times 1q, which is 3q, and 3 times 1, which is 3. And then the minus 4 comes down. Now we do not multiply to the negative 4 or the minus 4 because it's not in parentheses. So now we have to combine like terms. 3 and minus 4, or positive 3 and negative 4, are like terms because they're both constants. So if we combine those together, negative 4 plus 3 gives us negative 1. So the answer here would be 3q minus 1. Now, the next example we're going to do is example 3, and it's also going to require us to simplify. So let's have the problem negative 1/2 times the sum of 6m plus 4 plus 2m. Now, the first thing we're going to do is distribute the negative 1/2. This is going to be negative 1/2 times 6n and negative 1/2 times 4. Well, negative 1/2 times 6n is going to give us negative 3n, and negative 1/2 times 4 is going to give us minus 2. Now we're going to add the 2n. The next step is going to be to combine like terms. Negative 3n plus 2n are like terms, so that's going to give us negative 1n minus 2, since we're combining the coefficients. So my final answer can be negative 1n minus 2, or you can leave it as negative n minus 2. Now the step I skipped here is negative 1/2 times 6n and negative 1/2 times 4. Now you could actually write that step if you want to, but you don't have to. If you want to pause the video and do B by yourself, you can. Now in B, you're going to take 7 minus 4 times the quantity 3/4 x minus 1/4. Here's the biggest mistake you do not do. Do not subtract 7 minus 4. You have to follow order of operations. And order of operations says you have to multiply first. So we are going to multiply the negative 4 times everything in parentheses. Now once again, I'm going to write this step down, and you can skip it. But we're going to multiply negative 4 times 3/4 x, and we're going to multiply negative 4 times negative 1/4. So now that's going to give us 7. What's negative 4 times 3/4 x? It's just going to give us negative 3x. Here's the mistake people make. Students make this mistake all the time. If you're distributing a negative, which we are here, we have to take a negative times a negative, which gives us a positive. Don't ever forget that you have to distribute the negative 4, not just 4. So negative 4 times negative 1/4 gives us positive 1. And now we combine like terms. Like terms, negative 3x, plus we can combine 7 plus 1, which is 8. We could also leave it as 8 minus 3x. Either one of these would be an answer that is correct. In our last example, which is example number 4, we're going to use this in a real-life application. So it says each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies. Interpret each expression. So, if we know each ticket costs $7.50, it says each person in a group buys a ticket, a medium drink, and a large popcorn. We don't know how many people are going to the movies. So we know that it's going to cost $7.50 for every person that goes. That's for the ticket. Plus, each person buys a medium drink. Well, each person buys a medium drink, so it's $2.75 times X. Plus, a large popcorn. A large popcorn is $4, so we could put 4x. Now, these are all like terms, since they have the same variable with the same power. We add these all together, so we add all the coefficients, and that gives us 1425. And then we don't forget the x. So what does this represent? Well, the expression 14.25x indicates the total cost per person. This is how much each person is going to pay if they went to the movie theater to buy a ticket, a medium drink, and a large popcorn.